Have you ever wondered what it would feel like to stand at the very edge of everything, to reach the boundary where reality itself fades into the unknown? Tonight, we are going to explore something extraordinary, something that challenges everything you thought you knew about space and infinity. The universe stretches endlessly in every direction, without walls, without limits. Yet somehow you are trapped inside a sphere, a bubble with edges you can measure. A boundary that moves, that shifts, that closes in on you with every passing second. This is the paradox at the heart of existence. The universe has no edge, and yet it does. Both truths are real, both exist at once. As we drift through the darkness together, you will discover why the universe's edge is stranger than you think. You will see how time itself becomes a prison, how light can travel for billions of years and still never arrive, how entire galaxies slip beyond reach and vanish from your future forever. If you are curious about these cosmic mysteries, take a moment to like this video and subscribe to join us on more journeys through the unknown. And now, let the silence of space guide you deeper into the cosmos. Welcome to Sleepy Science Stories. Right now, in some quiet corner of the cosmos, a galaxy slips past an invisible threshold and disappears from our future. The motion is silent, inevitable, ongoing at this very moment. No alarm sounds to mark the crossing into unreachability. No warning announces the passage beyond the boundary. No cosmic bell tolls for what is lost to the void. It simply happens, as it has happened countless times before across billions of years. As it will happen countless times again in the eons ahead. As it is happening right now, somewhere in the immense darkness. Photons from more than 2 trillion galaxies stream toward Earth through the dark at this instant. They have been traveling for eons, crossing unimaginable distances through the void between stars. Each photon carries a story from the distant past, a message from ancient times. Each one began its journey when the cosmos was younger, when stars were forming, when galaxies were evolving. Each photon is a messenger crossing the abyss. Yet most of that ancient light will never find us here on Earth. It will never complete its journey across the expanding void between galaxies. The distance grows too fast for the light to overcome. The space expands too quickly for the photons to bridge the gap. The universe itself conspires against their arrival. We exist within a sphere stretching nearly 62 billion light-years in every direction, enclosed by a boundary we can watch forming in the present moment. This sphere defines everything we can ever know about the universe from our position. Everything we can ever measure or detect with any instrument. Everything we can ever interact with in any way imaginable. Everything we can ever touch or understand or reach. Past that edge lies infinity, endless and beyond knowing. A cosmos so vast that our observable universe becomes infinitely small by comparison. A realm so immense that numbers lose all meaning entirely. An expanse so profound that comprehension fails even as we try. An infinity that stretches beyond imagination itself. We begin our journey into the strange edge of everything that exists. Something impossible unfolds before you at this very moment in time. The universe extends forever in all directions, boundless and without end. It goes on eternally outward in every possible direction you could point. Space continues outward, always outward, never stopping or reaching a boundary anywhere. It never encounters a wall or limit. There is no wall marking where the cosmos ends in any location. No final galaxy sitting at some ultimate distance in space. No edge where reality ceases to exist or transforms into something else. No border where existence gives way to non-existence. Galaxies stretch beyond galaxies endlessly into the infinite dark. Stars beyond stars without limit across all of space. Structures beyond structures extending into distances the mind cannot truly grasp or comprehend. Patterns beyond patterns, repeating into the unfathomable void. Yet you stand at the heart of a sphere with edges you can measure down to the finest detail. This bubble surrounds you completely on all sides, defining the limits of your cosmic existence. This boundary is real and measurable through observation. Scientists can calculate its position with extraordinary precision using mathematical equations. Both truths hold simultaneously without contradiction in logic. Both appear to contradict one another in fundamental ways. Both seem to defy basic logic about what can be true. Both are real despite the paradox they create. This is not a mistake of observation or measurement error. This is not a failure of understanding or incomplete data. This is not an illusion created by limited instruments. This is reality as it truly exists in the cosmos. This is the nature of existence itself. Welcome to the most profound puzzle in cosmology, where infinity itself arrives with boundaries, where the limitless becomes limited by the very laws that govern existence, where the boundless is somehow bounded by time and space working together, where the infinite meets the finite in paradox, where contradiction becomes truth. Consider this carefully and let it settle in your mind like snow falling gently. Take a moment to let the question truly sink in deeply. Allow the strangeness to wash over you like waves. Let the impossibility become possible in your understanding. If you wonder whether the cosmos has an edge, the answer whispers no quietly into the darkness. Space does not end at some distant location you could travel to. It does not terminate at some distant boundary like the edge of a map showing known lands. It does not stop existing at any point you could name or mark. It continues without barrier or wall. Space continues outward without barriers of any kind, without borders drawn anywhere, without any kind of universal fence marking where existence ends. It simply continues without cessation into the infinite beyond. It goes on forever in all directions. Galaxies stretch beyond galaxies in an endless progression through space, each one containing hundreds of billions of stars burning bright. Structures beyond structures forming patterns that repeat across cosmic scales, patterns beyond patterns extending into the unfathomable distance beyond sight. Clusters of galaxies, superclusters of clusters, filaments and voids forming the cosmic web. The universe organized into structure at every scale, reaching into distances so immense that numbers lose all meaning entirely. Where billions become trillions and trillions become incomprehensible to the human mind, where counting itself becomes meaningless. The universe, confirmed through countless patient observations across decades of careful measurement and analysis, is likely infinite in its extent. Most cosmologists working today believe it continues forever without end. It goes on without boundary through all of space. It never stops or terminates anywhere. But here arrives the twist that transforms everything you thought you understood about reality. You cannot witness all of it from your position in space. The infinite cosmos remains forever beyond your complete understanding. You cannot journey to all of it in any amount of time available. You cannot even gather light from all of it with any telescope ever built. Despite dwelling in an infinite cosmos that extends forever, you are contained within a bubble, a finite sphere with definite boundaries in all directions. This bubble has measurable limits, genuine edges that scientists can calculate with precision using mathematical equations derived from observation. And those edges are drawing closer to you right now, this very second. The boundary contracts as time passes inexorably forward. The walls close in as the universe ages. The boundary is not built from matter or energy or any physical substance. No physical wall obscures your view of distant realms or blocks incoming light from far away. Nothing solid stands between you and the farthest galaxies visible in the sky. No barrier of atoms prevents observation or detection. No veil of dust or gas obscures the view. Instead, the edge emerges from something far more mysterious and fundamental. Time itself creates your enclosure and defines your prison without escape. The age of the universe sets your limits absolutely. The finite past constrains your view like a cage. Light moves at exactly one speed through the void, roughly 186,000 meters per second. This is the cosmic speed limit built into the fabric of reality itself. The maximum velocity at which anything can travel through space under any circumstances. Nothing moves faster through the vacuum of space, not particles of any kind known to physics, not information or signals of any type, not influence or causality across distance, not even gravity itself travels faster. This cosmic speed limit has remained constant since the universe began roughly 13.8 billion years ago. It is built into the fabric of space-time itself as a fundamental constant of nature. It does not change with time or location anywhere. It is the same everywhere in the cosmos without exception. It is woven into reality itself. Now, weave these two truths together carefully and you encounter a wall. Light from distant regions has been racing toward Earth since the beginning of time, traveling at maximum speed through space. But it has not arrived yet because the distance is too great. The universe is old, but not infinitely old as we might wish. Light has been traveling through space, but not for infinite time. Time had a beginning, and that beginning limits what we can see. Some light will reach us tomorrow as it completes its journey from nearby. Some will arrive in 1,000,000 years, having travelled all that time through space. Some will arrive in 1,000,000,000 years, carrying images from galaxies we have never seen before. Some will arrive in 10 billion years, showing us structures we cannot yet imagine. But vast expanses of space sit so far away that their light will never complete the journey to us. The distance is too great for the time available since the Big Bang. The time is too short for the distance involved in reaching us. The math does not work out in favour of arrival. That unreachable distance defines your edge with mathematical precision. It marks the boundary of everything you can ever observe from your location in space. Scientists name this boundary the cosmic horizon, and it surrounds you in all directions perfectly. It is perfectly spherical, centered exactly on your location in space. It follows you as you move through the cosmos wherever you go. You carry your horizon with you like a shell. Everything inside this sphere represents the observable universe from your vantage point, the only region you can possibly detect or interact with in any way. The only portion of infinity accessible to your instruments and observations, the only fraction of reality you can touch. Everything beyond remains forever hidden from your view, separated not by distance alone, but by the very structure of space-time itself. Not by physical barriers, but by temporal limits imposed by cosmic history. Not by walls, but by time itself. You could build a spacecraft capable of travelling at light speed, the fastest velocity physics allows under any circumstances. You could point it toward that horizon with perfect aim and precision. You could accelerate without stopping for as long as you wish. You could maintain that speed for eternity, never slowing down, never deviating from your course by even a fraction. You could burn fuel forever in pursuit of the edge. You would never reach it despite your best efforts. The boundary would move away faster than you could approach it. The boundary would recede at exactly the rate needed to keep you from reaching it. The horizon would recede, always remaining just beyond your grasp no matter how long you travelled. It would mock your efforts with its eternal retreat. This gets stranger still when you consider other observers throughout the cosmos. Your horizon is not the same as someone else's horizon in a different location. An observer on a world in the Andromeda galaxy, 2.5 million light years away from Earth, witnesses a different sphere centered on their location. Their cosmic bubble overlaps with yours, but is not identical to yours in content. Portions of their observable universe intersect with yours, showing the same galaxies, the same structures, the same cosmic features you can both observe. But vast regions they can see remain invisible to you, lying beyond your personal horizon in space. Similarly, you can see regions invisible to them beyond their horizon. Every point in space has its own cosmic horizon, its own bubble, its own edge marking observability from that specific location. Every observer in the universe sees a unique window into the infinite whole. Every perspective is singular and unrepeatable anywhere else. Every view is precious and unique. Infinity contains countless edges, countless boundaries throughout all of space, each one real and physical in its effects, each one unique to its observer and their position. each one defining a different perspective on the whole of existence, each one a different window into the infinite. We dwell in the universe that is both boundless and bounded simultaneously, eternal in extent yet limited in observation from any point. Infinite in scope yet trapped within cosmic bubbles of observability. Endless yet finite from every perspective. But the details of this puzzle reveal something even more unsettling about the nature of existence itself. Something that challenges our deepest assumptions about reality and our place within it. Something that makes us question what it means to be an observer in an infinite cosmos. Something that forces us to reconsider everything we thought we knew. Something that changes how we see ourselves forever. You are the exact center of the observable universe from your perspective right now. This is not metaphor or poetic approximation. This is not a figure of speech or simplified explanation for laypeople. This is literal, measurable truth verified by mathematics. This is how reality works. Stand anywhere on Earth, anywhere in the galaxy, anywhere in the cosmos imaginable, and the same principle applies without exception or variation. You occupy the middle of a sphere that extends equally in all directions from you. No direction is privileged over any other direction. No direction extends farther than any other into space. All directions are equivalent in their reach. Move one step to the left and your sphere moves with you perfectly. The center shifts because you shifted your position in space. Travel 1,000,000 light years across the galaxy and nothing changes about your situation. The bubble follows you perfectly wherever you go, always centered on you, always the same size. You cannot escape your centrality. This is not an illusion or a trick of perspective that could be corrected. This is not an artifact of measurement that better instruments could resolve. This is fundamental cosmic geometry, a direct consequence of how light propagates through space and time. A consequence of the finite speed of light combined with the finite age of the universe, a feature built into the structure of reality itself, an inescapable aspect of existence. Picture yourself standing in an enormous dark warehouse with a single flashlight in your hand. The beam illuminates a circle around you, creating a sharp boundary between what you can see and what remains in darkness. The lit area surrounds you symmetrically in all directions equally. You are always at its center, no matter where you stand in the warehouse. You cannot position yourself off-center from the light. Walk forward through the warehouse and the circle moves with you in perfect synchrony. The lit area never changes shape or size as you move, but different parts of the warehouse come into view ahead while others fade behind you into darkness. Objects appear at the edge ahead as you approach them. They cross through the illuminated region as you pass them by. They disappear into darkness behind you as you move away from them. The circle of light is eternally centered on you. Your cosmic horizon works exactly this way, except the flashlight is time itself and the warehouse is infinite in extent. The sphere of light around you represents the region from which light has had time to arrive since the beginning. Beyond lies darkness, not because light does not exist there, but because it has not yet reached you across the vast distance. Not because those regions are empty, but because their light is still traveling toward you. Not because they are different, but because time has not allowed their photons to complete the journey. Every observer in the universe experiences this same phenomenon from their unique position. An alien civilization 3 billion light years away sees their own sphere, their own horizon, their own observable universe centered on them. They stand at the center of their bubble, just as you stand at the center of yours. They are no more or less privileged than you are in position. They too believe themselves central to what they can observe. Some of the galaxies they can detect exist beyond your reach, invisible to you forever, no matter how long you wait. Their light has had time to reach them, but not time to reach you across the greater distance separating you. Meanwhile, you can see galaxies that remain eternally hidden from them due to distance. Your light has reached you, but not them across the space between your locations. The cosmos reveals itself differently to every observer, granting each one a unique window into infinity. No two perspectives are identical in content or view. No two views show exactly the same portion of the infinite whole. This makes every perspective precious and singular in the cosmos. Every view is unrepeatable and special. This creates a staggering realization that deepens the more you contemplate it carefully. No observer can see the entire universe from any location. No location, no matter how advantageous, offers a complete view of existence. No position grants privileged access to the whole of reality. The cosmos plays no favorites in what it reveals. Even if you could somehow survey every galaxy in your observable region meticulously, catalogue every star precisely, map every structure down to the smallest detail imaginable, you would still have examined only a tiny fraction of what exists throughout all of space. The full universe extends far beyond what any single observer can detect from their location. The infinite whole dwarfs every finite part infinitely. The ratio between what you see and what exists is infinitely small. Infinity ensures that everyone sees merely a sample, a cosmic preview, never the whole show. The complete performance remains forever beyond reach of any observer anywhere. The full story is never told to anyone, but here comes something that makes this even more mysterious and unsettling. Your observable universe is not just large by human standards of measurement, it is incomprehensibly vast by any standard you could apply. The sphere surrounding you measures roughly 92 billion light-years across from one edge to the opposite edge. That distance contains approximately 2 trillion galaxies by current estimates, each holding hundreds of billions of stars burning bright with nuclear fusion. Each star potentially hosting worlds orbiting in habitable zones, each world potentially harboring complexity and perhaps life. Each world potentially telling its own story across billions of years. The numbers become incomprehensible quickly as you try to grasp them. Your mind cannot hold them in any meaningful way. Your imagination cannot truly picture them or give them scale. Numbers this large lose meaning to human consciousness. Yet this entire region, this vast cosmic domain that exceeds all human understanding, represents only a minuscule portion of total existence. If the universe is truly infinite, and most evidence suggests it is, then your observable sphere is infinitely smaller than the whole. 0% of infinity, no matter how you calculate it. No matter how large your bubble grows over time, infinity remains infinitely larger by definition. The fraction is always 0. Your bubble contains everything you can ever see, measure, or interact with by any method. Every photon that strikes your eye or your telescope comes from within this sphere exclusively. Every scientific discovery ever made, every astronomical observation ever recorded, every piece of data about the cosmos originates from inside these boundaries. Nothing from outside has ever reached you or ever will. You are cosmically isolated in a profound sense, separated from the rest of infinity by unreachable limits built into the laws of physics themselves, by boundaries that cannot be crossed or circumvented by any means, by walls made of time and distance. What determines the size of your bubble lies at the heart of the puzzle itself. The answer involves the strange relationship between distance and time in an expanding universe. The interplay between cosmic age and light travel across space. The dance between space and time. Light deceives you constantly about distance in subtle but important ways. The photons that arrive at your telescope tell stories, but those stories require careful interpretation to understand correctly. Look at a galaxy 13 billion light-years away, and you see light that departed 13 billion years ago from its source. The photons have been travelling for most of the age of the universe across expanding space. Simple mathematics suggests that galaxy sat 13 billion light-years from Earth when it released those photons originally. This seems logical and straightforward based on travel time alone. This makes intuitive sense to human minds. Wrong. Profoundly wrong in ways that matter deeply. Completely wrong in ways that change everything. The galaxy was actually much closer when the light began its journey towards you, perhaps only a few billion light-years away at emission time. By the time those photons reach your telescope today, that same galaxy now sits far beyond 13 billion light-years from us. Perhaps 30 billion light-years or more in current distance. The light travelled through expanding space, and space itself betrayed the measurement during the journey. The expansion stretched the separation during the photon's travel time across billions of years. The fabric of the cosmos expanded beneath the racing light. This deception reveals something profound about cosmic distance, something that challenges our intuitive understanding of space. When astronomers report distances to far objects, they often use light travel time as a convenient measure. They measure how long light spent crossing space, counting the years of the journey. A galaxy whose light took 10 billion years to arrive gets labelled as 10 billion light years away in common parlance. But that number only tells you when the light departed from its source, not where the galaxy sits now. It tells you about the past state of the galaxy, not the present state. It gives you the look-back time, but not the current distance. It tells you history, not geography. Space expanded during the journey in ways that alter the calculation significantly. The galaxy drifted farther away while its light approached you, carried by the expansion of space itself beneath the travelling photons. The current distance exceeds the light travel distance by enormous amounts, often by factors of 2 or 3 or more. Sometimes the difference is staggering. Consider the most distant galaxies visible today in our deepest observations of space. Their light has been travelling for over 13 billion years, almost the entire age of the universe since the Big Bang. The photons began their journey when the cosmos was young, hot, and much smaller than it is now, when the first stars were just forming from primordial gas clouds, when the universe was unrecognizable compared to today. Simple calculation suggests they sit roughly 13 billion light-years away based on travel time. Reality tells a different story, one far stranger and more complex. Those galaxies now reside over 46 billion light-years from Earth by current measurement. The light has been travelling for 13 billion years through space, but space expanded beneath it during the journey dramatically. The fabric of the universe stretched by enormous factors over time, carrying the galaxy away even as its light moved toward us steadily. The galaxy drifted away while its photons struggled across the cosmos, making slow but steady progress through expanding space. By the time the light arrives at your telescope today, the galaxy sits more than 3 times farther than the light travel time suggests. This expansion factor creates the discrepancy between measurements of different types. The difference is not a small correction, but a fundamental feature. This factor applies everywhere across the cosmos at all distances. Double the light travel time and you get a current distance that is more than double in reality. Triple the time and you get more than triple the distance. The relationship is non-linear and grows with distance. The relationship between light travel time and actual distance grows increasingly non-linear at greater separations from us. The mathematics becomes complex, requiring general relativity to properly describe the expansion. The edge of the observable universe sits far beyond what simple light travel calculations would suggest naively. Light from the most distant visible regions has been travelling for nearly the entire age of the universe, approximately 13.8 billion years. Yet those regions now sit approximately 46 billion light-years away, more than 3 times the light travel distance. This expansion factor varies with cosmic history, depending on how fast space was growing at different times. Early expansion was rapid after the Big Bang, then slowed as gravity pulled, then accelerated again recently as dark energy dominated. The history of expansion is written in the distances we measure. This defines the radius of the observable universe, what cosmologists call the particle horizon formally. The farthest distance from which light has had time to reach us since the beginning of time itself, the boundary of all that is observable. Multiply by 2 to account for all directions around you, and the observable universe measures roughly 92 billion light-years across. This sphere contains everything observable from your location, everything detectable by any instrument, everything accessible to measurement or interaction by any means. Nothing beyond this distance can be seen right now, no matter how powerful your telescope becomes. No instrument, no matter how sensitive or advanced, can overcome this fundamental limit. The light simply has not had time to arrive yet from farther distances. The universe is too young for more distant photons to complete their journey to you. Time has not yet allowed those photons to cross the space. But here comes the twist that transforms this from merely interesting to deeply unsettling. The particle horizon is not the only edge that matters for understanding cosmic isolation. There exists another boundary, far more troubling, far more absolute in its implications. This second edge is called the event horizon, and it does not mark what you can see now in the present. It marks what you can ever see, even given infinite time into the future, even if you wait forever without end. Consider a galaxy that sits beyond your current observable universe at this moment. Light from that galaxy has not reached Earth yet because the universe is not old enough for the photons to complete their journey across space. But given enough time, given millions or billions of years of waiting patiently, that light will eventually arrive at your location. Wait 10 billion years patiently, and photons from previously invisible galaxies will complete their journey across the cosmos. New regions of space will enter your observable sphere, revealing cosmic structures never before seen by anyone anywhere. The particle horizon will expand outward in all directions, encompassing more of the universe over time. You would expect this pattern to continue forever into the indefinite future, endlessly revealing more of the cosmos. Wait long enough, wait trillions of years if necessary, and eventually light from any galaxy, no matter how distant, should reach Earth. Given infinite time ahead, everything should become observable eventually. Every structure should eventually enter visibility from your position. Every galaxy should eventually send us its light across the void. Every corner of the cosmos should eventually reveal itself. Wrong. Profoundly, disturbingly wrong in ways that shake our intuition about time and space. Completely wrong in ways that change what forever means. Some galaxies will never become visible to you, not because time runs out, but because space expands too quickly between you and them. The universe is not just expanding outward in all directions. It is accelerating, picking up speed as it grows older. The expansion is getting faster with each passing moment. The event horizon marks the boundary between galaxies whose light will eventually reach you, and galaxies whose light will never reach you, no matter how long you wait. Between the reachable and the forever unreachable in the future. Between connection and eternal isolation through all of time. Between what you can know and what you cannot. Light from galaxies beyond the event horizon is moving toward you right now at this very moment. It is crossing space at the speed of light, heading in your direction with unwavering velocity. The photons race toward you at maximum possible speed allowed by physics. But the space between you and those galaxies is expanding faster than light can cross it. The gap grows faster than light can close it despite the photon's motion. The distance increases despite the photon's progress toward you. The race is rigged against a rival. The light makes progress, moving steadily forward through space, covering enormous distances every second. But the finish line moves away faster than the light approaches it. The photons run full speed on a treadmill that accelerates beneath them, constantly increasing its rate. They never gain ground in net distance to you. They never close the distance to you overall. They are trapped in an endless race they cannot win. This boundary sits closer than the particle horizon in space. The event horizon currently lies at roughly 16 billion light-years from Earth by calculation. Galaxies beyond this distance will never be observed by us, no matter how long we wait for their light. Not in a billion years of waiting patiently, not in a trillion years of patience through time. Not ever through any means imaginable, not even if the universe lasts forever. Light from these galaxies is permanently locked out of your future. The cosmos contains regions that exist, that are real, that are filled with galaxies and stars and possibly even life, but that remain forever beyond your reach. Forever beyond any possible observation or detection by instruments. Forever cut off from knowledge. Now here comes the part that makes this genuinely disturbing and unsettling to contemplate. The event horizon is not fixed in place over time. It is not a permanent boundary that remains stable forever without change. It is shrinking inward toward you, contracting as time passes inexorably, closing in around you like walls. Galaxies that are currently observable will cross the event horizon in the future and vanish from view forever. Every second that passes, galaxies slip past this boundary into the unreachable. Every moment of time, the observable universe loses content permanently. You are watching the cosmos erase itself from your future, slowly but inevitably. You are witnessing a cosmic vanishing act in slow motion. This happens because the universe is not just expanding outward uniformly, it is accelerating, picking up speed as it grows older. Something called dark energy fills all of space uniformly, pushing the universe to expand faster and faster over time. This mysterious energy works against gravity's attraction, driving cosmic expansion to accelerate. Dark energy dominates the energy content of the cosmos now. This acceleration moves the event horizon inward, bringing the boundary closer to you. Galaxies that are safely within your observable universe today will eventually cross this contracting boundary and fade from sight. They will redshift into invisibility as space expands between you exponentially. They will disappear from the catalogue of observable objects forever. They will be lost to observation permanently. The edge is closing in around you inexorably with time. In roughly 100 billion years from now, galaxies beyond our local gravitational group will have crossed the event horizon. Their light will redshift into wavelengths you cannot detect with any instrument conceivable. They will fade from view entirely, not because they dim or die, but because space between us will expand so rapidly that light can no longer bridge the gap. Future observers will see a far emptier cosmos than we do today. They will look out at the night sky and see only a handful of nearby galaxies in their local group. They will inhabit an island of galaxies surrounded by apparent cosmic void in all directions. A lonely patch of matter in an ocean of expanding space, a small cluster floating in darkness. Yet that void is not truly empty of matter or structure. It never was empty at any time. Countless galaxies continue existing beyond the horizon, burning their stars, forming their planets, evolving their structures according to physical law. Expansion has simply carried them beyond observation range, beyond any possible detection by instruments. The universe remains full, rich, complex, teeming with structure throughout all of space. Only the connection breaks between observers across distance. Only the observational link severs due to expansion over time. Only the ability to see them is lost. This raises philosophical questions about the meaning of existence itself, questions that touch the deepest foundations of reality. If something exists but cannot be observed, detected, or interacted with in any way, does it meaningfully exist from your perspective? Can you claim knowledge of something that provides no evidence of itself to you? Is existence relative to observation and connection? Does a tree falling in a cosmic forest make a sound if no one can ever hear it? This is not merely a thought experiment or abstract puzzle for philosophers to debate in ivory towers. It describes the actual future of cosmic observation, waiting ahead for all observers. The literal fate of astronomical knowledge over time throughout the cosmos, the destiny of understanding itself. But space expansion does more than just hide distant galaxies behind unreachable horizons in the future. It fundamentally alters the nature of the cosmos you inhabit, changing the very structure of observable reality. To understand how expansion creates both your edges simultaneously, we need to examine the mechanism itself carefully. And the details reveal something profoundly strange about the structure of existence itself, something that defies intuition at every turn. Space is not just a stage where cosmic events unfold passively, a passive arena where matter and energy interact according to laws. Space itself is dynamic, growing, creating new distance between objects without moving them through itself. This expansion happens everywhere simultaneously, at every point in the universe at once. Not just in some regions, but in all regions equally. Not just between some galaxies, but between all galaxies. Pick any two galaxies separated by a great distance across the cosmos. Measure the space between them carefully, noting the precise separation with instruments. Wait a billion years and measure again with equal precision. More space exists between them now than before the waiting. The gap has widened significantly over time. Nothing pushed the galaxies apart through space physically. No force acted on them to move them away. No mechanism moved one away from the other physically through space. No engine drove them apart. Instead, new space appeared in the gap between them. The distance grew because the universe added length to the separation, inserting new space between existing space. The fabric itself expanded. This process continues without limit or constraint anywhere. Space can expand as rapidly as the conditions of the universe permit, unbound by the cosmic speed limit on matter. And here comes the key point that makes everything possible. There is no cosmic speed limit on the expansion of space itself. Light cannot exceed 186,000 meters per second through space. But space itself can expand faster than this without violating any physical law. The distinction is subtle but absolutely critical to understanding cosmic horizons. The speed limit applies to motion through space, to objects moving from one location to another through the fabric of space-time. It does not apply to the growth of space itself, to the creation of new distance between points in the fabric. Space can break the speed limit that matter cannot. This distinction creates the cosmic horizon and all the strangeness that follows from it. Light from distant galaxies travels toward you at the maximum possible speed allowed by physics, moving as fast as physics allows under any circumstances. But the space between you and those galaxies expands, growing as the universe ages. If space grows slowly enough compared to the speed of light, light makes progress across the expanding distance. The gap decreases over time despite the expansion working against it. Eventually, the light reaches you after a long journey through space. But if space grows too rapidly compared to light speed, light cannot overcome the expansion. The distance increases despite the light's motion toward you steadily. The photons run toward you but lose ground with every passing moment. They will never arrive at your location no matter how long they travel. The boundary between these two regimes defines your cosmic horizon precisely. Light from galaxies where space expands slowly enough will eventually reach you, perhaps in millions or billions of years of travel time. Light from galaxies where space expands too rapidly will not reach you, not now and not ever in the future. The horizon marks the transition between reachable and unreachable precisely in space. Now, calculate how fast space expands at different distances from you. This requires understanding the Hubble constant, a number that describes the expansion rate of the universe at the present time. The current value sits around 70 kilometers per second per megaparsec by modern measurements. That seemingly complicated unit breaks down simply when you examine it carefully. For every megaparsec of distance, roughly 3.3 million light-years, space expands by about 70 kilometers per second. Double the distance and you double the expansion speed proportionally. Triple the distance and you triple the expansion speed accordingly. A galaxy 2 megaparsecs away sees space expanding at 140 kilometers per second. A galaxy 10 megaparsecs away sees space expanding at 700 kilometers per second. The expansion rate scales linearly with distance, a direct proportion throughout all of space. Push far enough away and you reach a distance where space expands at exactly the speed of light. Light from a galaxy at that distance makes zero progress toward you despite moving at maximum speed. The photons move at light speed through space, but space expands beneath them at light speed. They hold perfectly still relative to you despite their motion through space. They run on a treadmill, moving at exactly their speed. Beyond that distance, space expands faster than light can travel through it. Photons from those galaxies lose ground every second that passes. They move forward through space, but the distance to you increases overall. This distance marks your cosmic event horizon precisely, the boundary beyond which light will never reach you. Calculate it using the Hubble constant, and you get roughly 16 billion light-years. That number represents the edge of your cosmic future, the limit of what you can ever observe. But the calculation changes over time because the expansion rate itself changes. Dark energy is causing expansion to accelerate, to pick up speed over cosmic time. The Hubble constant is not truly constant despite its misleading name. It is increasing as the universe ages and dark energy dominates. As expansion accelerates faster, the event horizon shrinks inward toward you. Galaxies that are currently within reach drift beyond it inevitably. The boundary contracts, cutting you off from more of the cosmos with each passing moment. This acceleration does not just hide distant galaxies from view temporarily, it fundamentally limits what you can ever learn about the universe. Every galaxy that crosses the event horizon takes information with it permanently. You lose access to an entire cosmic region, an entire chapter of universal history, an entire collection of data about how the cosmos evolved. The observable universe does not just shrink in content, in the number of visible galaxies you can count. It shrinks in potential knowledge, in the questions you can answer through observation and measurement. It shrinks in understanding itself. Future civilizations will inherit a lonelier cosmos, not because galaxies disappear or die, but because the universe hides them beyond horizons. Because expansion severs the observational connection permanently across space. Because the walls close in around every observer. Now consider what happens at truly enormous distances, far beyond even the event horizon. Far beyond the 16 billion light-year boundary we just discussed. Space expands so rapidly that galaxies move apart at many times the speed of light. A galaxy 100 billion light-years away sees space between it and you expanding at roughly 7 times the speed of light. The gap widens at speeds that seem impossible, but are perfectly allowed by physics. Nothing violates physical law here, despite appearances to the contrary. No cosmic speed limit breaks or bends under strain. The galaxies themselves are not moving through space faster than light. They are not travelling, not journeying from one location to another at superluminal speed through the fabric of space-time. Space between them is growing, creating new distance faster than light can cross it. The distinction matters absolutely and changes everything about what is possible. It is the difference between impossible and real in physics. Special relativity forbids objects from moving through space faster than light. This is an absolute prohibition, a fundamental law that cannot be violated under any circumstances. But general relativity places no such limit on the expansion of space itself. Space can grow as fast as the equations permit, as fast as the energy content of the universe dictates. At sufficient distances from any observer, space expands faster than light, separating galaxies permanently and completely. This creates multiple layers of unreachability, multiple boundaries within boundaries at different scales. Some galaxies sit beyond the particle horizon because their light has not had time to reach you yet. Wait long enough and these will become visible eventually. Some galaxies sit beyond the event horizon because their light will never reach you due to accelerating expansion. Wait forever, and these remain invisible permanently no matter what. Some galaxies sit so far beyond the event horizon that space between you and them expands at many times the speed of light. These are the most unreachable objects in the universe by far. They exist in regions so distant that no causal connection can ever link them to you. No light can bridge the gap between here and there. No signal of any kind can cross the distance ever. No particle can make the journey across the space. No information of any kind can pass between here and there in either direction. These regions are not just unobservable in practice due to technical limitations. They are fundamentally disconnected from your cosmic neighborhood by the laws of physics. They might as well exist in separate universes entirely, completely cut off from interaction. Yet they are part of the same universe you inhabit right now. They obey the same physical laws that govern your region of space. They emerged from the same Big Bang event that started everything. They share the same cosmic history and evolution over billions of years. Expansion has simply carried them beyond any possibility of interaction or observation. This raises profound questions about the nature of existence that philosophy and physics struggle to answer satisfactorily. If regions of space are forever causally disconnected from each other, do they meaningfully share a universe? Is the cosmos one unified whole, or is it fragmented into causally isolated bubbles that happen to be called by the same name? Are these separate realities or one reality viewed from different perspectives? Does unity require connection? These questions move beyond physics into metaphysics and philosophy, yet they emerge directly from the mathematics of cosmic expansion. They are not idle speculation, but consequences of observed reality and confirmed theory. The edge is not just a boundary in space dividing regions into categories. It is a boundary in causality itself, a limit on the very concept of influence and connection. A wall built from the laws of nature, but expansion does something else that is equally strange and revealing about cosmic history. It affects the light you do receive in ways that tell stories about the past. To understand your edges fully in their complexity, we need to examine what expansion does to photons during their journey across the cosmos. And those effects tell you how old, how large, and how unreachable the universe truly is. They allow you to see into the past directly with telescopes. They enable predictions about the future with confidence and precision. They turn light into a cosmic time machine. Light traveling through expanding space changes character during its journey in measurable ways. The expansion stretches the light itself physically, increasing its wavelength, shifting it toward the red end of the electromagnetic spectrum. This effect is called cosmological redshift, and it grows stronger with distance traveled. The farther light travels through expanding space, the more it stretches during the journey. Light from nearby galaxies shows minimal redshift, barely detectable even with sensitive instruments. Light from galaxies billions of light years away shows substantial redshift, easily measurable with modern telescopes. Light from the most distant galaxies shows extreme redshift, sometimes increasing wavelengths by factors of 10 or more dramatically. Visible light shifts into infrared wavelengths, invisible to human eyes. Ultraviolet light shifts into visible wavelengths we can see. X-rays shift into ultraviolet frequencies we can detect. The light arrives dramatically altered from how it was emitted by the source, transformed by its journey through expanding space. This redshift allows astronomers to measure distance with remarkable precision and confidence. The amount of redshift directly correlates with how much space expanded during the light's journey. Greater redshift means the light traveled through more expansion, implying greater distance and longer journey time through space. By measuring redshift carefully with spectroscopy, you can determine how far away a galaxy sits and how long its light spent traveling across the cosmos. But redshift does more than just indicate distance between objects. It reveals the rate of expansion at different cosmic epochs, different chapters in universal history. Light from very distant galaxies shows that the universe expanded at different rates in the past compared to now. By comparing redshift across many galaxies at different distances systematically, astronomers can reconstruct the entire expansion history of the cosmos over billions of years. They can determine when expansion was decelerating, slowed by gravity pulling matter together. They can identify when expansion began accelerating, driven by dark energy pushing space apart. They can measure how dark energy influences the growth of space over billions of years of cosmic evolution. The edges of your observable universe become visible through careful redshift measurements across the sky. The most distant galaxies show the most extreme redshifts, approaching theoretical limits where light stretches to enormous wavelengths. Beyond a certain redshift value, galaxies fade into invisibility completely, not because they are inherently dim objects, but because their light shifts entirely out of detectable wavelengths. This creates a practical horizon separate from the theoretical ones we've discussed so far. You cannot see beyond a certain redshift threshold because the light becomes undetectable by instruments, shifted beyond the sensitivity of any detector we can build. But redshift has another effect that makes distant observations even more challenging and limits how much you can learn from far objects. The expansion of space reduces the energy of photons as they travel through the cosmos. Light shifts to longer wavelengths, and longer wavelengths carry less energy per photon by physical law. A photon that starts as high-energy ultraviolet light might arrive as low-energy infrared light after traveling through billions of years of expansion. The energy loss is not absorbed by anything along the way. It is not converted into another form or transferred to some intervening medium. The energy simply dilutes into the expanding space, spread across the growing volume of the universe. This effect dims distant galaxies dramatically, making them appear far fainter than they would in a static universe. A galaxy 10 billion light-years away appears far dimmer than an identical galaxy 1 billion light-years away, not just because of increased distance, but because expansion has sapped energy from the light during its journey. Each photon arrives with less energy than it carried when emitted from the source. This makes observations near the cosmic horizon extremely difficult, pushing telescopes to their absolute limits. The most distant galaxies emit plenty of light when photons leave their stars originally. But by the time that light reaches Earth after its long journey, it arrives redshifted, energy depleted, spread thin by expansion across billions of years. Detecting these galaxies requires enormously powerful telescopes and long exposure times, gathering light for hours or days to collect enough photons. The James Webb Space Telescope was designed specifically to detect these faint, red-shifted signals from the edge of the observable universe. Its infrared sensors capture light that has been stretched beyond visible wavelengths into the infrared spectrum. Now combine redshift effects with the multiple horizons we've explored throughout this journey. Light from galaxies approaching the event horizon shows increasing redshift as they near the boundary. As a galaxy approaches the edge, its light stretches more and more dramatically over time. The wavelength increases exponentially as it nears the boundary. The energy decreases correspondingly, making detection harder with each passing moment. And the galaxy dims gradually, fading gradually from view over cosmic time. Eventually, the light redshifts beyond detection, shifting to wavelengths no instrument can capture. The galaxy fades from view completely, crossing into invisibility before it formally crosses the event horizon mathematically. You lose observational contact with the galaxy while it remains technically within your cosmic sphere. This creates a fuzzy boundary around the hard edge, a twilight zone where galaxies gradually disappear from view. The event horizon marks the point beyond which light will never arrive, a sharp mathematical boundary in space-time. But the practical observational horizon sits slightly closer in space, marking the point beyond which light becomes too redshifted to detect with instruments. Future observers will watch galaxies fade into this fuzzy boundary over billions of years of observations. They will see distant galaxies dim gradually over time, redshift progressively toward longer wavelengths, and vanish slowly as expansion carries them toward the event horizon inexorably. The universe will appear to be emptying around them, erasing itself galaxy by galaxy over incomprehensible timescales. Yet nothing about those galaxies changes fundamentally in physical terms. They continue existing exactly as before, but crossing into invisibility. They continue burning stars in nuclear fusion processes. They continue forming planets from protoplanetary disks of gas and dust. They continue evolving complex structures according to physical law, possibly hosting civilizations that wonder about the cosmos just as we do. Only the observational link breaks between observers across space. Only the connection severs due to expansion over time. Expansion carries them beyond detection, beyond knowledge, beyond any possible interaction or communication. The edge does not just limit what you can see at this particular moment in time. It defines what the universe means to you personally, shapes your entire cosmic reality. Everything beyond the horizon might as well not exist from your perspective functionally. It cannot affect you in any way whatsoever. You cannot affect it in any way imaginable. No information can pass between you and it in either direction. The horizon creates cosmic isolation more complete than any physical barrier ever could, more absolute than any wall or divide could be. But there is another layer to this puzzle that deepens the strangeness significantly. The edge you see today is not the edge you saw in the past or will see in the future. The horizon moves through time, changing position relative to galaxies, revealing some structures and concealing others. And that motion reveals something profound about the structure of cosmic time and the flow of observable reality through history. Your cosmic horizon expands by roughly 1 light-year every year as the universe ages. New regions of space become observable as their ancient light completes its journey to Earth finally. Every second that passes, photons from previously invisible galaxies cross into your cosmic sphere. Every moment of time, new territory enters observability for the first time ever. The particle horizon grows continuously outward, revealing cosmic territory that was always there, but remained hidden by the finite speed of light and the finite age of the universe. Your observable universe increases in volume with every tick of the clock, steadily encompassing more space. But this growth is deceptive, masking a darker truth about the future ahead. While the particle horizon expands outward, showing you more of the ancient universe from long ago, the event horizon contracts inward, cutting you off from more of the present universe right now. These two boundaries move in opposite directions, approaching each other through time. You see farther into the past as ancient light arrives from greater distances across billions of years of travel time. Simultaneously, you become disconnected from more of the current universe as expansion carries present regions beyond reach permanently. The edge moves differently depending on which edge you measure, creating a complex dynamic over time. Consider what this means for cosmic observation and what you can learn from the night sky. The farthest galaxy visible today emitted its light over 13 billion years ago, when the universe was less than 5% its current age. You see this galaxy as it was in cosmic infancy, young and full of newly formed stars from primordial gas. You witness its early evolution, its first generation of stellar formation from hydrogen and helium. You observe structures from when the cosmos was fundamentally different in temperature and density, but that galaxy has changed dramatically since then over billions of years of evolution. It has evolved according to physical processes and gravitational dynamics. It has matured through countless generations of stars living and dying. Perhaps it has merged with other galaxies through gravitational interaction and collision. It now sits over 46 billion light-years away from us, having been carried by expansion into the distant cosmos. You cannot see its current state whatsoever. The galaxy's present condition remains hidden beyond your horizon, beyond any observation you could make. Every galaxy you observe appears as it was in the past, not as it is now in the present. Look at a galaxy 1 billion light-years away and you see it as it was 1 billion years ago in its history. You witness its past, not its present state or current condition. Look at a galaxy 10 billion light-years away and you see it as it was 10 billion years ago. You see it when the universe was much younger than today. The observable universe is not a snapshot of cosmic structure at one moment in time. It is not a photograph showing everything simultaneously at one instant. It is a backward-looking cone through time showing different epochs at different distances from you. The farther you look into space, the farther back you look in time necessarily. Distance and time become intertwined inextricably in observation. This temporal structure creates strange possibilities that challenge intuition about existence. A galaxy could have already been destroyed by some catastrophic event, torn apart or consumed by a black hole. But you continue seeing it healthy because light from before its destruction keeps arriving at your telescope. The galaxy appears active and vibrant in your observations, burning bright with stellar formation and structure. But it no longer exists in its current location now. It may have ceased to exist millions or billions of years ago. You observe ghosts, images of cosmic structures that may have changed dramatically or ceased to exist entirely. The past reaches out to you through ancient photons that have travelled for eons across space. Now combine this temporal effect with the moving event horizon, and the picture becomes even stranger. Some galaxies you can see today will cross the event horizon in the future as expansion accelerates. Light currently arriving from these galaxies will eventually stop coming to you. The stream of photons will end permanently as the galaxy recedes. You will watch them freeze at the boundary, their evolution appearing to slow as redshift increases. You will watch them fade from view gradually, dimming over billions of years. And finally, you will watch them disappear entirely, crossing into permanent invisibility beyond the horizon. Meanwhile, other extremely distant galaxies will enter your particle horizon for the first time in cosmic history. Their ancient light will finally complete its journey, having travelled for nearly the entire age of the universe across expanding space. These photons will reveal cosmic structures never before observable by anyone, showing you galaxies that formed shortly after the Big Bang from primordial matter. Your window into the cosmos shifts constantly through time, changing both content and character. The observable universe changes composition over time, not just because galaxies evolve naturally through physical processes, but because different galaxies enter and exit observability through the moving horizons. Some ancient galaxies become visible for the first time as their light reaches us after billions of years of travel. Some more recent galaxies fade beyond the event horizon and vanish from the catalogue of observable objects forever. The inventory of observable cosmic structures is dynamic, constantly changing as horizons move through space and time. This creates a cosmic traffic pattern, a flow of galaxies through your observational window over eons. Galaxies enter your observable sphere from the deep past as their ancient light finally arrives after immense journeys. They cross through your observational window as you watch their evolution unfold over billions of years of cosmic history. Eventually, they exit your observable sphere toward the future as they cross the event horizon and fade from view permanently. The observable universe acts like a moving window sliding through space-time, showing different parts of the cosmos at different times. The rate of this traffic depends fundamentally on cosmic expansion and how it changes over time. In a decelerating universe where expansion slows down over time, the event horizon would recede outward, keeping pace with or outrunning the particle horizon. More galaxies would enter observability than exit it through the boundaries. The observable universe would grow in content as well as size, accumulating more galaxies over cosmic time. But in an accelerating universe where expansion speeds up over time, the event horizon contracts inward toward you. More galaxies exit observability than enter through the particle horizon. The observable universe empties over time despite growing in apparent size, a paradox of cosmic evolution. We live during the transition between these regimes, a pivotal moment in cosmic history. For most of the universe's past history, expansion was decelerating as matter's gravity slowed the growth of space. The attractive force of mass pulled against expansion throughout the universe. The observable universe steadily accumulated content as more galaxies entered visibility over billions of years of cosmic time. The cosmic catalogue grew richer and more complete with each passing age. But about 5 billion years ago, dark energy began dominating over matter in the cosmic energy budget. Expansion started accelerating, driven by this mysterious energy pervading all of space. The event horizon began contracting for the first time in cosmic history. We exist during the crossover period right now, when the observable universe reaches maximum content before beginning its long, slow decline into emptiness. Future observers will inherit a shrinking catalogue of observable galaxies, watching their universe appear to empty gradually. They will see the particle horizon expand just as we do, revealing ancient light from increasingly distant regions of space. But the event horizon will have contracted dramatically by then, cutting them off from vastly more present cosmic structure. The moving edge will have shifted the observational window to show less variety, less structure, less cosmic richness overall. The edge moves relentlessly forward through time, and the view changes with it inevitably. What you can see today differs fundamentally from what your ancestors could see billions of years ago. What your descendants will see differs from your current view of the cosmos. The cosmos reveals itself differently to observers at different times in history. The universe is not democratic in revealing its secrets. But there is something else about your edges that makes them even stranger than we've explored so far. The particle horizon and event horizon are not the only boundaries that matter for understanding cosmic isolation completely. There is a third edge, far more subtle, far more mysterious and profound in its implications. This boundary does not mark what you can see or what you can reach in the future. It marks the limit of what could have ever influenced you throughout all of history, shaped you, affected your existence. This is the edge of causality itself, the boundary of cause and effect across space-time. Light from the most distant visible galaxies has been travelling for nearly the entire age of the universe, crossing most of cosmic history. But light is not the only thing that travels through space-time, not the only form of cosmic communication possible. Information, influence, cause and effect all propagate at the speed of light or slower through space, never faster. Nothing can send a signal faster than light through space by any known means. Nothing can exert influence across distance faster than light can cross that distance. The speed of light is not just a limit on vision or observation of distant objects. It is a limit on causality itself, on the very concept of one thing affecting another across distance. Now consider carefully a region of space beyond your particle horizon, hidden from your view completely. Light from that region has not reached you yet, because the universe is too young for the journey. But more importantly, nothing from that region could have reached you by any means whatsoever. No signal of any kind, no particle of any type, no influence of any nature could have travelled from there to here. That region could not have affected the formation of Earth billions of years ago when our planet formed from a protoplanetary disk. It could not have influenced the evolution of life on this planet over billions of years of natural selection. It could not have played any role in the development of human civilization or consciousness over millennia. It is causally disconnected from your entire past, completely separate from your history. This creates a boundary called the past light cone in the language of relativity theory. It marks the region of spacetime that could have possibly influenced your present moment through any physical means. Everything inside the past light cone could have sent signals that reached you by now since the Big Bang. Everything outside could not have reached you, not through any process or mechanism known to physics. Your past light cone is actually larger than your current particle horizon, because the universe was smaller and denser in the past. Regions that sit beyond your horizon today were much closer billions of years ago, when the universe was young and compact. Light from those regions could have reached Earth long ago in the distant past, even though light emitted today from those same regions will never arrive at your location. Your past light cone encompasses everything that could have ever influenced you throughout cosmic history since the beginning. It defines your causal history, the complete set of events that shaped your existence from the Big Bang to now. But your past light cone is not the same as your future light cone, and this asymmetry matters deeply for understanding cosmic isolation. Your future light cone marks the region of space-time that you could possibly influence going forward into the future. It extends outward from your present moment, encompassing everything that could receive signals sent by you today or in the future. In a non-accelerating universe, your future light cone would eventually encompass the entire cosmos given enough time. Signals you send today could reach any galaxy anywhere, no matter how distant, if you wait long enough. Universal communication would be possible in principle across all of space. But in an accelerating universe like ours, your future light cone has definite limits imposed by physics. Some regions of space are moving away so rapidly that signals you send will never reach them, no matter how long you wait or how powerful the signal. These regions lie beyond your event horizon in the opposite time direction from your past. They are causally disconnected from your future, just as regions beyond your particle horizon are disconnected from your past. You can never influence them by any means available to physics. This creates a disturbing asymmetry that violates our intuitive sense of cosmic reciprocity and fairness. Your past light cone is larger than your future light cone in spatial extent. You have been influenced by more of the universe than you can influence in return through any action. The cosmos that shaped your present existence is larger than the cosmos you can shape in the future. Expansion has narrowed your sphere of influence permanently, contracted your reach irreversibly over time. Now combine these boundaries with the moving horizons we've discussed throughout this exploration. your future light cone is shrinking as the event horizon contracts inward toward you. Fewer galaxies remain within your sphere of influence with each passing moment of time. The cosmos you can affect grows smaller with every tick of the cosmic clock. Meanwhile, your past light cone continues expanding in the historical direction into the distant past. More regions that influenced your past become visible as their light arrives after long journeys across billions of years. But you cannot influence those regions in return, cannot send signals back to them across time. The connection is one way only, flowing from them to you, but never back in time. This creates a profound cosmic asymmetry that challenges our understanding of cosmic reciprocity and balance. The universe that shaped you is not the same as the universe you can shape through your actions. You are the product of a larger cosmos than you can affect through any means available. You owe your existence to regions you can never reach or influence by any method. Causality flows inward from a vast region of space-time, but flows outward only to a limited, shrinking sphere around you. The edges of causality are not aligned symmetrically, creating an imbalanced cosmic relationship. The universe is not fair in how it distributes influence, but there is yet another boundary, even more subtle and harder to grasp conceptually. This edge does not mark what you can see, what you can reach, or what could have influenced you throughout history. It marks something more fundamental, the limit of cosmic structure itself, if such a limit exists. This is the edge of the observable matter distribution, the boundary where galaxies might end. Surveys of galaxies across the sky reveal large-scale structure in the universe, patterns that repeat across billions of light years. Galaxies cluster into groups, bound by gravity into stable systems. Groups cluster into superclusters, vast collections of thousands of galaxies spanning hundreds of millions of light years. Superclusters form vast filaments and walls separated by enormous voids where galaxies are rare or absent. This cosmic web extends as far as telescopes can see in every direction we look. But does it continue forever without change beyond our view? Or does it eventually end or fade somewhere? If the universe is infinite and matter is distributed roughly uniformly throughout all of space, then structure should continue indefinitely beyond the horizon we observe. No edge of matter distribution should exist anywhere in space. But if the universe is finite, with some boundary beyond observation, or if matter distribution becomes increasingly sparse at great distances beyond what we can observe, then structure might eventually fade into emptiness. Beyond some distance, galaxies might become so rare that the cosmos appears essentially empty, even though space continues existing. Current observations suggest matter distribution remains roughly uniform out to the edge of the observable universe at all distances we can measure. The density of galaxies does not appear to decrease significantly with distance in any direction we look. The universe looks similar everywhere we point our telescopes within our observable sphere. This implies that if the universe is infinite as theory suggests, structure likely continues beyond the horizon indefinitely. The cosmos beyond our view is probably filled with galaxies we cannot see, stretching on forever in patterns similar to what we observe. But we cannot confirm this assumption through observation by any method available. We cannot observe beyond the particle horizon by any technique known to science. The distribution of matter beyond remains unknown to us, perhaps fundamentally unknowable through observation. This creates an edge of knowledge separate from the edge of observation, a boundary of certainty and verification. You can see out to the particle horizon and gather data from within it using telescopes, but you cannot see what lies beyond or confirm that it resembles what you observe nearby. You can speculate based on theory and physical principles established here. You can theorize based on models and mathematics and symmetry arguments. You can extrapolate patterns you observe nearby to greater distances beyond observation, but you cannot observe directly or test conclusively through experiment. The cosmos beyond your horizon might be filled with galaxies in the same patterns as you observe, or it might be empty void devoid of structure or matter, or it might contain structures entirely unlike anything in your observable universe. All are consistent with current observations because observations cannot reach that far by definition. The edge of knowledge sits exactly at the edge of observation, perfectly aligned by necessity. Now layer all these boundaries together to see the full picture of your cosmic isolation. The particle horizon marks what you can see now in the present moment. The event horizon marks what you can ever see in the future given infinite time. Your past light cone marks what could have influenced you throughout history since the Big Bang. Your future light cone marks what you can influence going forward into the future from now. The edge of cosmic structure marks where matter distribution might end, if it ends at all anywhere. Each boundary is distinct and separate from the others in its implications. Each one matters for different reasons and different questions about reality. Each one reveals a different aspect of cosmic reality and your place within it. Your observable universe is defined by multiple edges layered on top of each other in complex ways, some expanding outward with time as the universe ages, some contracting inward inexorably as expansion accelerates, some fixed by cosmic history permanently since the Big Bang, some changing with cosmic evolution over billions of years. The edge is not a single boundary in space that you could point to or locate. It is a complex, multi-dimensional structure of overlapping limits, each revealing a different aspect of cosmic isolation and connection. And all of these edges, every single one without exception, emerge from one fundamental fact of physics. The speed of light is finite, not infinite as we might wish for observation. If light travelled infinitely fast across space instantaneously, no horizon would exist anywhere in the universe. You could see everything instantly across all of space at once. Every galaxy, no matter how distant, would be observable at this very moment from any location. Every region of space would be accessible to observation and influence without delay. Distance would matter only for travel time of objects, not for observation of light. But light moves at a fixed speed dictated by the structure of space-time, and that finite speed creates boundaries inevitably. Combined with cosmic expansion and acceleration, it creates multiple boundaries moving in different directions through time. The edge of the universe, you cannot escape it by moving or travelling anywhere in space. You cannot overcome it with technology or cleverness or determination. It defines the structure of your cosmic existence, absolutely and permanently for all time. But here comes the final twist that makes this story complete and profound. The edge you perceive depends fundamentally on when you live in cosmic history. Observers in the distant past saw a different universe with different boundaries in different locations. Observers in the distant future will see a different universe still with dramatically different horizons. The edge moves through time relentlessly, changing the cosmos that observers can see from any location. In the early universe, shortly after the Big Bang event, the particle horizon was tiny compared to today. Only a small region of space was observable to any observer because light had travelled only a short time. The cosmos was young, and light had not had time to travel far across space. As the universe aged and time passed over billions of years, the particle horizon expanded steadily outward. More regions became visible as their light completed its journey across growing distances. The observable universe grew steadily larger with each passing billion years of cosmic time. For most of cosmic history, this growth meant an increase in visible content and observable structures. More galaxies entered observability than exited it through any horizon. The cosmic catalogue of known objects expanded continuously over time. Observers at different epochs could see more or fewer galaxies depending on when they lived in universal history. But the trend was generally upward over most of cosmic time, revealing more structures over billions of years. Then, about 5 billion years ago, something changed fundamentally in cosmic evolution. Dark energy began dominating the cosmic energy budget over matter and radiation. Expansion accelerated dramatically, picking up speed over time. The event horizon began contracting for the first time in cosmic history. For the first time ever since the Big Bang, galaxies began exiting observability faster than new ones entered through the particle horizon. The observable universe reached peak content and began declining in observable structure. We live near this peak in cosmic history, during this transition period. We exist during the era when the cosmos is most observable to any observer anywhere. Past observers saw less because the universe was younger and fewer galaxies had entered visibility through the particle horizon yet. Future observers will see less because expansion will have carried galaxies beyond the event horizon into permanent invisibility. Our epoch represents a special, privileged time in cosmic history overall. A brief window when the universe reveals itself most fully to observers from any location. This window does not last long by cosmic standards or compared to the total lifetime of the universe ahead. The age of maximum observability spans perhaps a few tens of billions of years total. Before this window opened long ago, the universe was too young for much to be visible. After this window closes in the future, expansion will have hidden too much beyond horizons. The total lifetime of the universe may extend for trillions upon trillions of years into an inconceivably distant future. The age of cosmic visibility is a brief moment, a fleeting era in an incomprehensibly long history. And that visibility is already declining even now as you read these words. Galaxies are crossing the event horizon at this very moment in real time. The observable universe is losing content second by second right now, irreversibly. The process is slow by human standards, imperceptible in a single lifetime or generation. But it is inevitable by cosmic standards, unstoppable by any means we can imagine. In another 50 billion years from now, the night sky will look profoundly different from any perspective. Many galaxies visible today will have faded beyond detection, redshifted into invisibility by expansion. The observable universe will contain far fewer visible structures than it does now. In 100 billion years, the change will be dramatic and shocking to any observer. Almost all galaxies beyond the local gravitational group will have disappeared beyond the event horizon. The cosmos will appear far emptier, lonelier, more desolate from any viewpoint. Yet nothing about the universe itself changes fundamentally during this time in its physical nature. Galaxies continue existing exactly where they were throughout space. Stars continue forming from clouds of gas according to physical law. Structure continues evolving throughout the cosmos over time. Only the observational window shifts in space. Only the connection severs due to expansion. This raises profound questions for future civilizations that may arise long after we are gone. Imagine intelligent observers arising in 100 billion years when the universe is far older than today. They emerge from evolution on some distant world. They develop science and technology through curiosity. They look out at the cosmos through powerful telescopes. They see a sparse distribution of nearby galaxies within their local gravitational group bound together. They see no cosmic microwave background because expansion has redshifted it beyond any possible detection with instruments. They see no evidence of the Big Bang or cosmic origin event from observations. They see no hint of cosmic expansion beyond their local gravitational system. What would they conclude about the nature of the universe based on this limited evidence available to them? Without distant galaxies to observe moving away, they could not detect or measure cosmic expansion reliably. Without the cosmic microwave background radiation filling space, they could not confirm the Big Bang origin or measure its temperature. They would develop cosmological theories based on a static, eternal, unchanging universe as their model. They would theorize that the cosmos has always existed in roughly its current form forever. And they would be fundamentally, completely wrong about cosmic history and reality, but they would have no way to know they are wrong through observation or experiment. The evidence would have slipped beyond their horizon forever, lost to expansion irretrievably. No experiment they could perform would reveal the truth about cosmic history to them. This illustrates a profoundly humbling fact about scientific knowledge and its limits. What you can learn about the universe depends critically on when you ask the question in cosmic time. Some truths about the cosmos are only discoverable during certain limited epochs of cosmic history. Outside those epochs, the evidence vanishes beyond horizons or redshifts beyond detection permanently. The universe stops revealing that particular secret to observers forever. We are fortunate. perhaps uniquely fortunate in cosmic history, to live during an era when cosmic history remains observable and testable. We can see the Big Bang's afterglow still glowing faintly in the sky as microwave radiation filling all of space. We can detect cosmic expansion by measuring galaxy redshifts across the sky systematically. We can measure dark energy's effects on acceleration through supernovae observations. We can study galaxies billions of light years away, seeing deep into cosmic history. Future observers far in our future will not have these advantages or this access to evidence. They will inherit a universe that hides its history behind impenetrable horizons. They will see a cosmos that appears static, eternal, unchanging, simple, and limited. And they will develop cosmologies accordingly, building theories that match their limited observations. Unless they discover records left by earlier civilizations from our era, preserved somehow across time. Unless they find evidence preserved from a time when the cosmos was more visible and revealing. Unless we, living during this window of observability, record what we see carefully and preserve that knowledge for the distant future in some durable form. This is not just scientific curiosity or academic interest for specialists to pursue. It is cosmic responsibility to future minds who will come after us in the distant future. We live during an era when the universe can be understood more fully than ever before or ever again. That era is ending slowly but inevitably with each passing moment of time. The knowledge we gain now might be the only knowledge obtainable about certain aspects of cosmic history. Once expansion carries the evidence beyond horizons, it is gone forever from any observer's reach. But the loneliness ahead is not just observational or scientific in nature. It is existential and deeply personal on an emotional level. Consider carefully what it means to be cut off from the rest of the cosmos by expanding space. Right now, in the present moment, in principle at least, communication with distant civilizations is possible if they exist anywhere. A signal sent today at light speed could reach a galaxy 10 billion light years away in 10 billion years of travel. The connection exists in principle, even if not in practice currently. The possibility remains open, even if no one is there to receive it on the other end. But once a galaxy crosses the event horizon into permanent invisibility, communication becomes absolutely impossible by any means. A signal sent toward that galaxy will never arrive at its destination, no matter how powerful or how long you wait. Space expands faster than the signal travels through it, defeating all efforts at communication. The message is lost to expansion, diluted across growing distance over time. Any civilization beyond the event horizon is permanently, absolutely unreachable by communication. You could send a transmission every single day for eternity, and none would ever be received by them. You could shout into the void forever without hope of reply. The cosmic postal service has hard, unyielding limits built into space-time itself. Now imagine you are that distant civilization in your thought experiment, reversing the perspective entirely. You exist in a galaxy beyond Earth's event horizon, in the opposite direction across the cosmos. You look out at the cosmos and see your own observable universe centered on your location. Earth sits beyond your event horizon as well in your sky, invisible and unreachable to you. Neither civilization can ever contact the other by any means whatsoever. Neither can even know the other exists through observation or detection. You share the same physical universe, both formed in the same Big Bang event, both governed by the same laws of physics throughout history. But you are cosmically isolated, permanently separated by expanding space between you that grows faster than light. You might as well exist in completely separate universes for all the interaction possible between you. No information can ever pass between you in either direction through any channel or method. Multiply this isolation by trillions or more across all of space. Countless civilizations could exist throughout the infinite cosmos, each one isolated in its own observable bubble. Each one seeing a unique slice of infinity from its particular vantage point in space. Each one believing they observe the universe when they observe only their tiny cosmic neighborhood. None can communicate with the others beyond their local gravitational group bound by gravity. None can confirm the other's existence through any observation or measurement. The universe might be absolutely teeming with intelligent life, filled with minds wondering about existence and meaning. Yet every civilization is fundamentally alone in the deepest sense possible, not alone in the sense that no others exist elsewhere in space. Alone in the sense that contact is physically impossible by any means known or imaginable. This is cosmic loneliness of the most profound order imaginable to consciousness, not isolation by mere chance or unfortunate circumstances of location in space. Isolation by the fundamental laws of physics themselves governing reality, not separation by distance alone that could theoretically be overcome. Separation by the very structure of space-time itself, by the nature of reality at its foundation. And that loneliness deepens inexorably over time as the universe ages. As expansion accelerates faster and faster under dark energy's influence, more galaxies cross the event horizon every moment. More potential civilizations drift beyond reach into permanent invisibility. The sphere of possible contact shrinks steadily with time. The cosmos becomes increasingly fragmented into isolated bubbles, each one causally disconnected from all the others. Eventually, far in the future, when the universe is incomprehensibly old, each gravitationally bound structure will inhabit its own island of matter in space. Surrounded by apparent void in all directions as far as telescopes can see, civilizations in those structures will see nothing beyond their local galaxies bound together by gravity. They will have no way to know that countless others exist just beyond their horizon. They will develop philosophies of cosmic uniqueness, believing they alone occupy the universe. They will feel utterly isolated in existence, alone in the cosmos, and they will be wrong about being alone in space. But the universe will provide absolutely no evidence to correct their misconception or inform them otherwise. They will be right to conclude they are isolated even if wrong about being unique. This is the ultimate consequence of the edge and its motion through time into the future, not just a limit on observation or knowledge of distant objects. A limit on connection itself, on the very possibility of cosmic community and interaction. Not just what you can see with instruments and telescopes. What you can touch, communicate with, share existence with in any meaningful way whatsoever. The edge defines the boundaries of your cosmic community absolutely and permanently. Everything inside your horizon can potentially be reached or contacted with signals travelling at light speed. Everything outside is forever separate, forever isolated, forever unknowable through any observation. But there is one more layer to this puzzle to complete our understanding. One more boundary that makes the edge even stranger than you imagined possible before tonight. This final edge does not mark a limit in space or time or causality. It marks a limit in explanation itself, in the very possibility of understanding why things are as they are. Consider this deep question carefully and let it settle in your consciousness. Why does the observable universe have the size it does? Why is the particle horizon 46 billion light-years away and not some other distance, smaller or larger? The answer seems straightforward and mathematical at first glance. Light has been travelling for 13.8 billion years since the Big Bang, and expansion has stretched distances during that time according to general relativity. Calculate the accumulated expansion using Einstein's equations of curved space-time, and you get 46 billion light-years as the current particle horizon. The size of the observable universe is simply what the age of the universe and the expansion history together produce through cosmic evolution over time. But this answer immediately raises another, deeper question that cannot be avoided. Why is the universe 13.8 billion years old specifically at this moment in time? Why did the Big Bang happen when it did in time? You might answer that the Big Bang was the beginning of time itself, so there is no meaningful when it happened. Time itself started with the Big Bang event according to standard cosmology and general relativity. There was no before in any meaningful sense that we can discuss or contemplate. But this response does not resolve the puzzle or satisfy the question deeply. It deepens the mystery and makes it more perplexing to consider. If time started with the Big Bang, then the universe has a finite age by definition. and that finite age produces a finite observable region with definite boundaries in space. The edge exists because time has a beginning in the past. Now ask the deepest question of all, the question that pushes beyond physics. Why does time have a beginning at all? Why did the Big Bang occur in the first place? Why does the universe exist instead of nothing existing anywhere? Here, you reach the edge of explanation itself, the boundary beyond which science cannot currently go. Physics can describe in detail what happened after the Big Bang, with impressive precision and accuracy. It can trace cosmic evolution forward in time with remarkable accuracy using mathematics. It can measure expansion rates, calculate horizon distances, predict future evolution with confidence. But physics cannot yet explain why the Big Bang occurred in the first place originally. It cannot account for the initial conditions that started everything in motion from nothing. It cannot say why this universe exists with these particular properties instead of other properties, or no universe at all existing. The edge of the observable universe ultimately traces back to the edge of scientific explanation itself. The boundary that limits what you can see is a direct consequence of the boundary that limits what you can explain about origins. And that boundary remains one of the deepest, most frustrating mysteries in all of physics and philosophy. Some theories attempt to push this boundary back further into the past beyond the Big Bang. Inflationary cosmology suggests the Big Bang was preceded by a period of exponential expansion called cosmic inflation. Quantum cosmology explores how universes might emerge spontaneously from quantum fluctuations in the vacuum without cause or explanation. Multiverse theories propose that our universe is just one among countless many universes in a larger structure called the multiverse. But none of these theories eliminate the edge of explanation completely, or answer all questions satisfactorily. They just move it to a deeper level, pushing it back one step farther into mystery. Inflation requires its own initial conditions to begin the process of rapid expansion. Quantum cosmology requires pre-existing quantum laws and principles to operate and produce universes. Multiverse theories require a metastructure or mechanism that generates universes according to some rules or laws. Each explanation rests ultimately on something unexplained or taken as given without justification or deeper explanation. The edge of explanation simply shifts to a deeper, more fundamental level without being eliminated entirely. Some philosophers and physicists suggest this edge might be truly fundamental and permanent in nature. Perhaps there are questions that have no answers, not because we haven't found them yet, but because they don't exist. Perhaps existence itself is brute fact, not explainable in terms of anything more fundamental than itself. Perhaps the universe simply is, without ultimate reason or cause beyond itself. This view accepts the edge of explanation as permanent and unbridgeable by nature or logic. It suggests that some boundaries cannot be crossed, not because of limitations in current knowledge or technology, but because of fundamental limitations in the nature of explanation itself. Other thinkers resist this conclusion strongly and remain optimistic about future discovery. They argue that every boundary is temporary, that every edge eventually yields to deeper understanding with time. They point to the history of science as compelling evidence for this optimism and confidence. Questions once considered permanently unanswerable have found answers through new insights and breakthroughs in understanding. Mysteries once thought permanent have dissolved through deeper theory and observation over centuries. Perhaps the edge of explanation marks only the limit of current knowledge, not the limit of knowable knowledge itself. This debate remains unresolved and intensely active in philosophy of science, but it connects directly to the edge of the observable universe in profound ways. Both boundaries raise the same fundamental question that haunts all of knowledge. Are there absolute limits to what we can know about reality? The observable universe clearly has an edge, a boundary beyond which observation cannot go by any means. Does knowledge have a similar edge as well, a boundary beyond which understanding cannot penetrate by any method? This question extends far beyond cosmology alone into all of science. It touches every field of science, every domain of human inquiry into nature and reality. Are there phenomena that are inherently, fundamentally unobservable by definition or principle? Are there questions that are inherently, permanently unanswerable through any investigation or method? Are there truths that remain forever beyond reach of any mind or intelligence, no matter how advanced? The cosmic horizon suggests strongly that the answer might be yes to all of these troubling questions. There are regions of space we cannot observe, not because our technology is currently insufficient, but because the structure of space-time absolutely forbids it by physical law. There are galaxies beyond the event horizon that we can never see, not due to practical limitations that might be overcome, but due to fundamental physical law itself. If observational limits exist in cosmology by necessity, might explanatory limits exist elsewhere as well throughout knowledge? The edge of the universe might be just one example of a more general principle about knowledge and its limits. Perhaps reality contains multiple edges, multiple types of boundaries beyond which knowledge cannot penetrate by any means. Or perhaps every edge is temporary and will eventually yield to deeper understanding with time and effort. Perhaps every horizon eventually expands as science progresses over centuries and millennia. Perhaps what seems unreachable today will become accessible tomorrow through insights we cannot yet imagine or predict. This remains one of the deepest, most important questions in philosophy of science, and the observable universe provides a concrete, measurable example where the question becomes urgent and testable. You stand at the center of a sphere with real, measurable boundaries in all directions around you. You can calculate the size of your cosmic bubble precisely using mathematics and observations from telescopes. You know what lies beyond in principle, at least in broad terms: more space, more galaxies, more structure, repeating in patterns. You can theorize about it using physical laws established here in the observable region. You can model it using mathematics and computation and simulations. You can speculate about it using reason and inference from patterns we observe. But you cannot observe it directly or gather data from it through instruments. The edge prevents you absolutely and permanently for all time ahead. This is not ignorance that can be overcome by building better telescopes or developing more sensitive instruments through technology. This is not a practical limitation that technology might someday solve through innovation and cleverness. This is a fundamental limit imposed by the laws of physics themselves, built into reality at its foundation. No technology conceivable can break through the event horizon or observe beyond it. No method imaginable can detect galaxies beyond the particle horizon whose light has not yet arrived. The edge is real and physical, not illusion or approximation. The edge is absolute and mathematical, not merely practical or temporary. The edge is permanent and unchanging in its existence, not subject to improvement or elimination. And that permanence raises profound questions about the nature of scientific knowledge and its limits. How do you study what you cannot observe by definition or principle? How do you test theories about regions beyond the cosmic horizon that provide no data to analyze? How do you confirm or refute ideas about the unobservable universe when observation is impossible by law? These questions challenge the very foundations of the scientific method and how we gain knowledge reliably. Science traditionally relies on observation, experiment, and empirical testing to validate theories against nature. But what happens when the subject of study is inherently, fundamentally unobservable by definition? Can science make claims about such things meaningfully or with confidence in their truth? Cosmologists have developed careful approaches to this difficult problem over decades of thought. They use indirect evidence from the observable region as clues to the larger whole. They apply mathematical consistency and logical coherence as guides to truth and reality. They invoke theoretical elegance and simplicity when choosing between alternatives that fit data equally well. They make assumptions about uniformity and homogeneity of space, extrapolating patterns from the observable universe to the unobservable regions beyond. They construct models that predict both observable and unobservable features, then rigorously test the observable predictions against data from telescopes and instruments. If the observable predictions hold up to scrutiny under testing, This lends some credibility to the model statements about the unobservable parts beyond the horizon. But this approach has inherent limits that cannot be overcome logically or methodologically. You can never directly confirm that the unobservable universe matches your models or theories about it. You can only show that your models are consistent with observations within your horizon. Multiple different models might fit the same observations perfectly, while making radically different claims about the unobservable regions beyond view. Which one is true about those distant regions we cannot see? You cannot know with certainty or absolute confidence through any method. The edge of the observable universe is also an edge of empirical confirmation and certainty in knowledge. Beyond it lies a realm where science becomes necessarily more speculative by nature, more dependent on theoretical reasoning and mathematical structure for guidance, less anchored by direct evidence and observation from instruments and experiments. This does not mean science cannot say anything meaningful about the unobservable universe at all. It means science says it with less certainty, with more dependence on untestable assumptions and principles that cannot be verified. The edge changes the nature of knowledge itself fundamentally. Inside the observable universe, knowledge is thoroughly empirical and testable through experiment and observation. Outside the boundary beyond the horizon, it becomes more theoretical and speculative in character. The boundary marks a transition in how we know, not just what we know about the cosmos. Now step back and view the full picture of your cosmic situation overall. You stand at the center of a finite bubble within an infinite cosmos stretching forever in all directions. This bubble has multiple edges of different kinds, each one marking a different kind of boundary with different implications. The particle horizon marks what you can currently see based on light travel time from the past to now. The event horizon marks what you can ever see given infinite future time ahead of you. Your past light cone marks what could have influenced you throughout cosmic history since the Big Bang. Your future light cone marks what you can influence going forward into the future from now onward. And beyond all these lies the edge of explanation itself, the boundary of why things are as they are. Each boundary is mathematically real and physically meaningful in different ways and contexts. Each one limits you in a different way with different consequences for knowledge and connection. Each one reminds you that despite living in an infinite universe, you are profoundly constrained and limited. You cannot see everything that exists throughout all of space in the infinite cosmos. You cannot reach everything in space through travel at any speed. You cannot know everything about reality through observation and measurement. The cosmos is vast beyond imagination or comprehension by any mind, human or otherwise, yet you inhabit only a tiny corner of it. And that corner is shrinking slowly but inexorably over cosmic time as expansion accelerates. The event horizon contracts inward relentlessly toward you. Galaxies fade beyond reach one by one into invisibility and isolation. Your cosmic community diminishes over time inevitably as the universe ages. The future is lonelier than the present moment we experience now. The present is lonelier than you realized before understanding these boundaries and their implications. But there is strange beauty in this isolation if you look carefully with open eyes and heart. The edge gives your existence a unique perspective, impossible to replicate anywhere else in all of space. Every observer sees a different slice of infinity centered on their location in space. Every consciousness experiences a unique window into the cosmos, unlike any other window anywhere. Your observable universe is yours alone among all observers throughout all of space and time. No one else anywhere in the cosmos sees exactly what you see from where you are right now. No one else occupies exactly your position in the cosmic web of space-time. This makes your perspective precious and singular among all perspectives possible. You witness a configuration of the cosmos that is unrepeated across all of space and time. Your view is singular and will never occur again exactly in the same way. And there is deep wonder in reaching toward the unreachable, striving to understand what lies beyond our grasp. The edge beckons to you across the void, challenging you to understand what lies beyond its boundary. You know galaxies exist beyond your horizon, based on theory and extrapolation from what you see. You cannot see them directly with instruments, but you know they must be there filling space according to the same laws. This knowledge transforms the darkness beyond your edge into something meaningful and profound. The void beyond your boundary is not truly empty or barren of structure or matter. It is full of light you cannot yet receive, starlight racing through expanding space at maximum speed, galaxies you cannot yet see burning bright with stellar formation and evolution over billions of years, structures you cannot yet imagine evolving according to physical law throughout the cosmos. The universe extends beyond your grasp infinitely, infinite and generous with reality and existence everywhere. The edge does not diminish the cosmos or make it smaller in total scope or scale. It frames your observable portion beautifully and makes it precious and meaningful to you. The boundary does not make the universe small or limited in extent throughout space. It makes your observable region special and meaningful to you personally. You cannot see everything in existence throughout all of space and time, but you can see wonders beyond counting within your sphere of observation around you. 2 trillion galaxies fill your cosmic sphere right now at this moment in time. Each galaxy holds billions or hundreds of billions of stars burning bright with nuclear fusion. Each star might host worlds orbiting in the habitable zone, where life could arise and flourish. Each world might harbour stories of complexity and evolution over eons of time. The observable universe alone contains more complexity than you could explore in countless lifetimes, more wonders than you could catalogue in eons of effort and dedication. And beyond your horizon, infinity waits patiently in the darkness beyond observation. Not empty or void or barren of structure or matter anywhere, filled with marvels you will never witness from your location in space. Other observers at other locations seeing other perspectives, experiencing other windows into the endless cosmos. You cannot see them or reach them through any means available to physics. You cannot contact them or communicate with them across the distance separating you. But knowing they exist somewhere changes the meaning of your isolation profoundly and deeply. You are not alone in an empty universe devoid of other minds or consciousness anywhere. You are one among countless observers throughout space, each seeing their own unique view of the infinite whole. Each one isolated by expanding space inexorably and permanently, yet each one part of the same vast cosmic tapestry. The edge separates you from others irrevocably across distance and time, yet the edge also connects you to something larger than yourself mysteriously and beautifully. It reminds you that your observable universe is not the entire universe that exists in reality. Your perspective is not the only perspective possible in all of reality throughout space. Your cosmic bubble is one among infinite bubbles throughout space, each centered on a different point. This is the paradox at the heart of everything we've explored tonight together. You live in an infinite universe, yet see only a finite portion of it from your location. You occupy the center of your cosmic sphere, yet that center is no more special than any other point. You are isolated from most of existence, yet connected to everything by the structure of space-time itself. The edge is the strangest feature of the cosmos when you truly contemplate it deeply with wonder. Stranger than black holes warping space-time into singularities beyond comprehension. Stranger than dark energy accelerating expansion mysteriously throughout all of space. Stranger than quantum mechanics and its counterintuitive paradoxes that defy common sense. Because the edge is not a thing you can point to or touch with instruments, it is not an object or a force or a tangible phenomenon in space you could visit. It is a consequence of fundamental reality itself at the deepest level of existence, a limit built into the very structure of existence by physical law and geometry. You cannot escape it by traveling anywhere in space at any speed. You cannot overcome it by clever thinking or innovation or determination. You can only accept it as part of your cosmic reality and existence. And in accepting it fully with wonder, you discover something profound about yourself and your place. The edge defines what you are as an observer in this universe we inhabit. You are an observer in an infinite cosmos with a finite view of it from your location. You are a consciousness aware of boundaries you cannot cross ever by any means. You are a perspective unique in all the infinite universe throughout all of space and time. The edge makes you possible in a deep sense fundamentally. Without limits on observation anywhere, there would be no distinct perspectives anywhere in space. Without boundaries in space-time, there would be no unique views into reality from different positions. The very thing that isolates you from infinity is the thing that makes you who you are. The universe could have been structured differently by different physical laws governing reality. It could have been small enough to see entirely from any point in space. It could have lacked expansion, allowing every galaxy to remain visible forever without motion. It could have been structured such that no horizons exist anywhere or ever in time, but it is not structured that way by the laws we observe and measure. The universe is infinite in extent, expanding in time, and horizon bounded by necessity of law. And you exist within it consciously, observing, seeing a fragment of the whole from your unique position. A beautiful, precious, singular fragment of infinite reality. This is why the universe's edge is stranger than you think before contemplating it deeply with wonder. It is not where space ends in some location you could travel to and observe. Space does not end anywhere in the infinite expanse that continues forever. It is not a wall or barrier you could touch with instruments or hands. Nothing physical blocks your view outward into the cosmos from your location. The edge is where observation ends, where causality ends, where knowledge reaches its fundamental limits imposed by reality. The edge is built from time and expansion interacting together over billions of years. From the finite speed of light and the accelerating growth of space over cosmic time. From the age of the cosmos and the structure of space-time itself at its foundation. The edge emerges naturally from the laws of physics themselves without exception anywhere. And it reminds you that infinity can have boundaries paradoxically and beautifully. That endless space can contain limits on observation from any point in that space. That the universe can be both boundless and bounded simultaneously and coherently without contradiction. Both eternal in extent and constrained in observation from anywhere in space. Both infinitely large in space and finitely observable from any location you could occupy. You stand at the center of a profound paradox in cosmic reality and existence, surrounded by edges in an edgeless cosmos that continues forever without boundary, contained within a bubble in a boundless universe without end in any direction, isolated from infinity yet connected to the infinite whole by space-time itself, limited by horizons yet part of infinity itself at the same time. This is your place in the cosmos right now at this moment. At the heart of wonder about existence and meaning, at the boundary of knowledge about reality and its nature, at the edge of everything that exists throughout all of space and time. Let this truth settle into your consciousness like starlight falling through the dark. You are witnessing something profound and rare. You are understanding something most of humanity will never grasp. You are seeing the universe as it truly is, in all its paradoxical beauty. And now, as this journey ends, let your eyes close. Let the cosmic story fade into dreams. Let the edge of everything become the edge of sleep. You are part of infinity, observing infinity, contained within infinity. You are the universe contemplating itself through eyes of wonder, and that is perhaps the strangest truth of all.